most of you know me. I'm Lauren Anderson. I'm a professor in the Physics and Astronomy department at WVU. My specialty is in radio astronomy. So this overall project has kind of two main thrusts. One is the engineering aspect, where you guys are going to be building a little radio telescope. And the second one is using the data that you take with your little radio telescope to understand something about our universe. The part of the universe that you are going to be sensitive to is the H1 emission, so the neutral hydrogen emission, from our own Milky Way galaxy. So that's why I picked this slide here. Here we have Mauna Kea, and then the Milky Way is this band of stars. And if you kind of look instead of the dark parts, you can see these dark lanes here. That's dust that is commingled with dense molecular gas. And what is not apparent is that in this same band is the H1 that your little radio telescopes are going to be sensitive to. So our goal again is to take your data and apply some scientific knowledge to understand the Milky Way, and it is my job to give you guys the tools to interpret your data as best you can. This little spectrum is something I pulled off of the internet. Your data will look fairly similar though, I believe. Those of you who have experience can back that up. This is called a spectrum. The y-axis is in mean antenna temperature. It's basically just a unit of intensity. So think of it as how bright something is. The x-axis is frequency. And so this is called a spectrum, which is intensity versus frequency. The frequency here is tuned by your little radio telescope. And so each one of these is a little measurement of the intensity at a given frequency. Now, it's not obvious now, but we actually can get tons of information out of these spectra. So we have what frequency the lines are at, and we also have the intensity of those lines, and we can turn both of those pieces of information into a better picture of our own Milky Way galaxy. And the neat thing is that this particular line of hydrogen is really, really bright. And so with a little tiny telescope and a little bit of experience, you can get some real science out of it. That's pretty rare. There's not much that you can do with a little tiny telescope that you're going to build in a few weeks. This is one of the coolest experiments that we can do. So what I'm going to be doing in the next couple of weeks is I'm going to be telling you about astronomy so you can better interpret your data. In these lectures, please ask tons of questions. This is not meant to fill up a lot of time. Yes?
So the spectrum that you got there.
Yeah.
So that's it's electrons going up and down in the hydrogen atom, right? That's what's causing it?
We will get to that.
Okay.
It's actually the electrons flipping their spin.
Okay.
But yeah, it's called a hyperfine transition in the hydrogen atom.
Okay.
But it is an electronic transition, yes.